So this will be our last video for inverses, video 3 of 3. And there's just a couple of things I want to address in this video. One are problems that look like this, where it's a composition of both an inverse and a regular function. And sometimes, like when you first look at them, they seem a bit intimidating and complex. But if you think about what is it asking for, what part is the inverse, what part is the normal trig function, it's not too bad. So I would start in the inside parentheses, and this thing that I'm circling right here represents an angle. So draw that angle. Draw an angle whose sine ratio is 1/4. And remember, sine sits in the first quadrant, so 1:4 ratio, since sine is positive, right? So 1:4 ratio. So there's your theta. And we don't really know what that theta is, but then that's okay. We can complete the triangle. The square root of 4, which is 16 minus 1, 15. So this missing side length is 15. But then it's okay because we don't really have to find the angle. We have to find the cotangent of that angle. And remember, cotangent would be the adjacent piece, over the opposite. So then I would say, that ratio is root 15 to 1. And that's it. So I don't even have to find theta. I just have to find a ratio of theta, which is nice. Otherwise, I would have to have a calculator to figure out what that angle is. Okay, so part B, same idea. Start on the inside. Arc cotangent is negative. So remember, arc cotangent, the geography of arc cotangent being negative, puts you in quadrant 2. So now you're over here, and you draw the cotangent ratio, so negative root 2 to 4. Remember, it's adjacent over opposite. And so even though that's our theta, that obtuse angle, find the hypotenuse. So root 2 squared is 2, plus 4 squared is 16, so 2 plus 16. So the hypotenuse is root 18, which I know I can simplify. And then do cosecant. Cosecant would be the hypotenuse over the opposite. So the ratio would be root 18, over 4. Or I could reduce that to 3 root 2 over 4. So, they're not too bad. Inverse tangent of 5/12, since it's positive, all positive ratios go into quadrant 1. So 5 to 12, there's the tangent ratio. It's our good friend, the 5, 12, 13 triangle, right? So there's theta. And then find the cosine of that, 12/13, adjacent over hypotenuse. So it's just good practice, I think, a little bit, because, so it's a bad 13, because, it just reviews, where do you draw arc sine when it's negative? So for arc sine being negative, remember, it's down in quadrant 4. It's a negative angle. So remember, it's that negative angle. But we don't need to necessarily know that. We just have to make sure we draw our triangle correctly. So negative root 3 over hypotenuse of 14. And then to do the Pythagorean theorem, 14 squared is 196, minus 3 is 193. So it's kind of an awkward number, root 193. And then the secant of that would be 14 over root 193. So the awkwardness continues. I don't believe there's any perfect squares in there. So you could call that 14 root 193 over 193. Okay. Now, certainly you can do the same thing in the reverse direction. Notice now the inverse functions on the outside, and that's okay. Still draw your triangle. Because the domains are different, an arc sine is not going to necessarily just cancel the sine and get 4 pi over 3. So, if I draw 4 pi over 3, so 4 pi over 3 sits that down here, right? And so 4 pi over 3, which is a 60-degree reference angle, means this is negative root 3. This would be 2. This would be negative root 1. So then now from that angle, do the inverse sine of that. Well, so I'm sorry. Figure out what that ratio is. What is the sine ratio of 4 pi over 3? The sine of that would be negative root 3 over 2. So now when I do the arc sine of that result, this, because of the limited domain of arc sine, automatically puts me in a brand new quadrant. It has to be down here in quadrant 4 as a negative angle. So here's negative root 3 to 2 ratio. So it's still a 60-degree reference angle, just like it was up here in this quadrant, but the restricted domain of arc sine has to be in quadrant 4. So then it's negative 60 or negative pi over 3. Okay, same thing's going to be true with this problem. Cosine of 3 pi over 2. So where is 3 pi over 2? Okay, so 3 pi over 2 is right down here, right? And so then what is the cosine value of that? Well, that's 0, negative 1, and cosine follows the x, so that's 0. So this part right here is 0. So now I have to do the arc cosine of 0. And again, remember, cosine's only defined in quadrants 1 and 2 when I do its inverse function. And since cosine follows x, the x value that we would be interested in would be actually at the top up here. At that point, 0, 1. So what angle is that in standard position? That's pi over 2, or 90 degrees. So my answer would be pi over 2. So again, the limited domain of arc cosine, I should say range of arc cosine, and the limited range of arc sine change where the triangles, where the ratios are. Well, yeah, I mean, they change where the triangle came from, right? The triangle came from quadrant 3. Here's the ratio, but as soon as I put that ratio into arc sine, it automatically defaults it to its, its restricted domain right there. Same thing with the cosine value. Okay, now the last piece is that I wanted to show you that your calculator doesn't have these inverse trig functions, right? Your calculator doesn't have inverse cosecant or inverse secant or inverse cotangent. So how do you type them into your calculator if you wanted to actually know what that angle is? So let me go ahead and flip my screen around and get to a graphing calculator and show you that. And so, your initial thing for, let's say, arc cosecant of negative 4/3. So your initial thought might be, if I can find, there is it. So your initial thought might be to do this, to do 1 divided by arc sine of negative 4/3. That, because we know that sine and cosecant are reciprocals, right? But there's the issue, right? There's our domain issue, because you can't have sine that's a bigger than a 4/3 ratio. I mean, bigger than a 1 ratio, right? I mean, think about what you just put in there. You just drew a sine ratio. Actually, it was negative, so down here, a sine ratio of negative 4. Sorry, I'm saying it right. You just got to write it right. Negative 4/3. Right? That doesn't make sense. You can't have that. So you actually have to draw, what does cosecant look like? Oh, okay. So cosecant is hypotenuse over opposite. So negative 4/3. So if I'm going to look at that from sine's perspective, that's negative 3/4. So that's what you have to put into your calculator. So I would type in inverse sine or arc sine of negative 3/4. In other words, take the reciprocal of this, because that's the function that you're going to evaluate. So let's go ahead and make sure, maybe just be in degree mode, just to get a better sense of how big this angle is. So I'm going to arrow down to degrees. There we go. Okay, so now when I do inverse sine, so inverse sine of negative 3/4. So I did the reciprocal of the ratio. It tells me, oh, it's a negative 48-degree angle, which is pretty reasonable, right? I mean, think about that angle there is about halfway through the quadrant. That makes sense. Okay. All right, so arc secant. So again, we don't have arc secant, so we're going to try to utilize arc cosine. So then when we drew the secant ratio, it would have been 10 over negative 9. So then what do I type in my calculator? I type in arc cosine of negative 9/10. So then I go to my calculator and I type that in. And the great thing is that the calculator automatically has the restricted domains defined. Oops, negative 9/10. There it is. So it should be an obtuse angle, right? Because that's how arc cosine, arc secant work. 154 degrees. Perfect. So then we get to our last one, which I just randomly came up with these numbers here. Arc cotangent of -2/3. So when I draw this cotangent, remember that's also in quadrant 2. Cotangents ratio -2 to 3. There's right. So I'm looking for an obtuse angle, but here's the problem, right? If I try to, I'm going to write it in red because it's a problem, right? If I try to do arc tangent of -3/2, right? Because that's what has happened. Every other one, we do the inverse function. For those of you, you might be anticipating this. If I try to do inverse tangent of -3/2, close that parenthesis, it's going to give me -56 degrees. That is not a -56-degree angle over here, right? That's not. I'm looking for obtuse. It gave me this angle down here, right? It gave me -56 degrees. Now, why did it do that? Because that's how tangent's defined, right? Tangent's defined in that quadrant. So it becomes a bit tricky with this cotangent because its reciprocal is not defined in the same location. Like secant and cosine, they pair up. Cosecant and sine, they pair up. So these are split. So how do you get up to that angle? Well, it is exactly 180 degrees apart since they are kitty corner to each other. So I could add 180 to that and get the answer. Or I could also pick a trig function that's defined in quadrant 2, which is cosine. So if I say, 4 plus 9, or if I do 2 squared is 4, 3 squared is 9, so that's root 13. I could also do inverse cosine of, let's see, -2/√13. That would get me the same answer as well. So I could add 180 to what I got on my calculator. Because again, I have to get back up in that quadrant. So hit 180. So that's what I would get. That's the angle. That seems like, it matches what it should be, the obtuse angle. Or, like I said, you could do inverse cosine of negative, I believe it was 2 divided by √13. And because inverse cosine's all automatically defined as a negative ratio in that second quadrant, should give us the exact same angle. So very, very cautious. And in fact, I think I put a note, right? Note. And I don't know which one to put here, but just say, when you're doing inverse cotangent, make sure you add 180 degrees to tangent, right? Somehow summarize what we just did here. Like, how do you evaluate arc cosecant? Oh, you can do arc sine, but do its reciprocal. How do you do arc secant? Well, you could do arc cosine, but do its reciprocal. But now for arc tangent, when it's negative, then you need to either when arc cotangent, when it's negative, you either need to add 180 or you need to, use arc cosine. Now, if I ask for like arc cotangent of +1/5, I could use arctangent of 5 because the positives line up. It's the negatives we have to be careful of. So, okay, so that completes our series of 3 videos on inverse trig functions. So take a look at the homework, see how that goes, and then certainly come in if you have any questions.